let's quickly recall what uh, what are the intention behind each of the codes, right? So quickly recall that there is a data set, right, which has sentences, and each sentence has a blank. We want to fill in the blank, and there are 5 options for each sentence. So our data set has the total size of 1040 such text, right, written in lines. All right. Okay, that's the text database, and as we know, we have 5 answers for each of them, right? You can see something like this. So out of the 5, which one is correct, right? That is here, right? But we could understand that first we need to read this. For reading that, we wrote a code called read data, and this code gives you the sentences, each of the sentence in S variable. There is a where is the location of underline which we need to fill, and the 5 words and the correct answer. Okay, so that is our first target. I just have to read. So that has been used inside this particular uh, script, right? So which actually reads that, and we have all the 5 parameters created like this. And at the end, you can see that whatever you read is not sufficient. You have to convert them into the form in the numerical form. Okay, so that reason we have written find the distinct words and convert the whole text into numbers, right? So 2 more codes, 2 more functions are given. One is find the distinct words. You can see, right? It finds out unique in S, right? S is our the complete array containing all the text, right? And the text to numbers, we try to convert every sentence into a numerical format, right? Okay, after comparing that with the distinct words. So this is what we have done. So let's run this once. So we'll get all the variables here once it runs. All right. So that's so far whatever we have written is running completely. Now there is a sorry, there is a mat file by the name my database. What are the variables present inside that? One is num z and c, right? So num z, if you see that, this contains the 5200 cells. So each cell contains, right, set of numbers corresponding to each of the word. Okay, so that's what it is. And there is a c, right? You can see the variable c here. That's also 5200. It tells that out of each of the category, every five row is corresponding to one sentence. Only one of them is correct. Okay, so which one is correct, you can identify that. So in the first set, first 5 numbers, third one is correct. Next 5 numbers, 6 to 10, first one is correct. In the sense, in the among the 5 sets of the second sentence, the first sentence is correct. Right answer, right? And okay, right. Right. So this is what has been saved now. So now actually I don't need anything else. I just have to use my database. That is the two variables present inside the my database to test and to train and test the machine. All right. Okay. So let us create a new file. So far what we did, it's just a pre-processing step, right? Everything everything we did so far, out of that only this saved file is enough for us. Okay, now let me do one thing. So let me create a new one, edit. Okay, I'll write complete sentence. Okay, complete sentence. This is the code which I am going to write. All right, so I don't want any other variable present, so we can do the here close and field. we start from there. Now we'll run that. Okay, so it's running now, everything is clear. Let's start with loading the required file. So which is the load required file? So I have to load it to say s is equal to, I'll assign that maybe this contains all my sentences, so I'll read my database. Okay, so in order to read, we know that there is a command that is a load command, right? So enter load, just type the name, that is my database. So let me try to run this section and check that. Yeah, so you can see that S is created. Now S contains two things. One is the C, other one is nums. Whatever is present inside the S will be okay here. So there is another way. Simply we can say that the load this thing is also possible. But you see what happens. Both the variables will be directly written to the workspace, right? So the num z and c will be right present in the workspace, right? So that's the difference. You can do whatever you want. Okay. So now this is what I'm doing. I'm reading it to a structure. That's why the name is given as S. From this, I'll try to find out what is actually length of my database. See, this is we prefer writing the general format of the code. Okay, so that's why. So n, try to read the length now. Read the length of any one of the variable that is present inside the S. So inside S, I know that we have two variables, either C or num z. You can read anything, but now you see, since the variables are not directly present in the workspace, you need to read it using the structure dot format. So that is S is my structure, S dot C. Okay, so let me try to run this. You see, 5200 is assigned to N. Okay, all right. So next, I don't want to see that. So I now, okay, let's do one thing. We'll try to print the data and check how this is going to look like. I know that. Okay, I'll take just 10 numbers. I just want to print randomly 10 sentences on my screen, right? So how it is present in the num set. That's what I want to check. Okay, so that's a loading part. Let's view this now. So for say a is equal to start from 1, go all the way till maybe 10. I'll try to print f printf, type which category it is. Category, and I'll write percentage d. I want to print a number. So category can be read from where it is. It's the C variable. C is inside S, right? So S dot, right, C, but I have to read the kth element. So C dot k. All right. Yes, that's a S printer, F printer. Now I want to print all the numbers in the NZ, because you see this num z contains the numbers corresponding to the kth element. So just try to print that. So F printf. So it means after this I'm going to print this, right? After the category and percentage d, now we'll print this. Okay, so F printf and percentage 5d. I want to give a space of totally I want to use 5. Okay, comma. Again, what I want to print is present inside the S. All right, S dot which what you want to print, the num z, right? Num z. Again, this is the kth element, but if you see the num z is what? It's a cell, right? Num z is a cell. So how do you access the cell? Cell will be accessed by using the flower brackets, correct? So that's the difference we need to remember. Other than that, everything. Okay, F printf, this is done. Once a line is finished, I want to go to a new line. Okay, so F, once again, F printf. I just want to do \n. And okay, I will see if my category is completed, then I want to go to a new line, right? I want to give a space between the categories. So what I do, I check that whether I printed all the 5. Once 5 is finished, that means I have to give a blank space between, right, the lines. Okay, so I will check that. So if the mod of the k, compare it with 5. If k mod 5 equal to 0, that means either you have 5 or 10 in each, correct? So if this is the condition, what you are supposed to do, go to a new, add a new line over f printf \n. So I go to a new line after one category is completed. You'll see this once we run this, okay? And there's a for loop which I want to, okay, save this and let's try to see, right? So you see the category, then space percentage d. This is the category space percentage d, which I'm reading from C of k. You see this is the first category and space, then the C of k. That's this. So immediately I'm saying that in my code, after this, print num z of k, right? Giving, using everything is percentage 5d. So 5 spaces are there. So you see, so 1 2 3 4 5. So 1 2 3 4 5, right? So there is a, if the number is lesser, right, I'm giving one space over there. Number is 3 digits, means you give 2 spaces, and so like that you print. Is it okay? Right, so complete sentence has been printed in the form of numbers. This is what we expected. So every line, you can compare all the 5 lines here, everything is same except the blank space area where you are trying to fill different numbers corresponding to the word you filled over. Out of which one is correct? How do you identify? Look at the category. So when you say it is 1, so this number 4366 is the right answer. Okay, we directly converted to this format. So now you see this is it's the proper format which the machines expect to process. Okay, so once we are sure that okay, this is good, we'll proceed further. Now we start with the building of the network. Okay, data is loaded, it is present in S, n holds the total size. Okay, now so out of these we'll give the inputs one by one, correct? So this complete data will go into the machine once. So how many inputs you have? Input is equal to 1. Okay, number of inputs equal to, let's give it as 1. Only one input. So again, it's a deep neural network, right? In the sense, it's a type of CNN. So what I'm expecting is I want to use maybe of the hidden layers of order maybe 100, 200, or maximum 500. These numbers will work normally. Okay, so let's define number of hidden layers. Number of hidden layers equal to how much? Let me define somewhere maybe 200, 250 or whatever. Okay, somewhere in the middle, we'll see. And you need number of the classes. Can you tell me how many number of classes we have in this data set? Either a given sentence Machine will say that it's a right answer or wrong answer, correct? So how many classes? Two, right? We have two classes. This is what I want to the machine to understand. Okay. Now, so start building that by giving the specifications such as the layers. Right. So we know that we have to define the layers by using uh, by specifying that like this. So you start with input layer. So input now is a sequence. You see, it's not image input. So previous problem, I think we used the input as an image input layer, correct? And we created the image database, right? So now it is not a it's not image, it's a sequence, right? You see 142 followed by 2522, 2954, 2927, 2297. This is a number, it's a series of numbers, correct? So the best suitable what you call network architecture, that is a neural network in the sense deep neural network suitable to handle the time series data. This is a series of data, right? Something like sampled at every interval of time. So that kind of data is effectively handled by a type of neural network called LSTM. Okay, so we are using that now. So you have to specify what is your input. Input is a sequence. Okay, it's a sequence input, sequence input link. All right, I have to specify now, right? What is the size? So size should be equal to number of inputs, correct? Okay, and all right, number of inputs. Okay, that's the thing. And right, I need to specify, right? Okay, let's build this, then we'll. So this is what, right? Number of inputs. Right. So this is the first layer. Then I will specify the first layer, which is nothing but the by LST. This is the, instead of CNN, right, convolutional 2D layer, we are using a different one, that is a by LSTM. Okay, by LSTM layer of, so specify how many hidden layers you expect. So that is number hidden layers. Number of hidden layers, right? I need to specify what I'm expecting at the output. So this is defined by output more. And you see, I'm using another layer of another hidden layers set. Okay, I'm going to use another LSTM layer. So that actually expects the input in which format, once again sequence only, right? So I am saying that give me the output, right, in the sequence format. Right, if I don't do that, it comes in a different format, and I cannot use the next by LSTM layer, and the output of this layer will not be suitable for that. Okay, let me go to the next one. As you know, right, you use a dropout, correct? So do you remember the concept of dropout? Dropout layer, right? Just to avoid the overfitting, right? You don't choose all the way getting updated every time, right? You choose a portion of your hidden layers to get updated. So you will specify what percentage, right? So I'll just say that drop out 20% every time, 0.2, right? Which means randomly 20% of your hidden neurons are dropped out during the training. Next training, that will come, some other will go. Okay, some other layers will not be trained. Fine, okay. Then that's a dropout. Then we need okay, this is the format, right? Every time you use a by LSTM, anyway, this is the input layer. This will not come once again. Okay, but by LSTM followed by dropout can repeat any number of times. Okay, as so right now we'll put say twice, and we'll check whether this is going to work. If it is not going to work, I'm going to increase. Okay, I'm going to add up another two lines of code. Okay, so let's repeat. That is by LSTM layer. Again, the same number of hidden layers. So I'll write number of hidden layers. Number of hidden layers, comma, right? Now you see, I don't want the output in a sequence, but because I'm going to generate the output. Okay, so specify out more. Tell that I don't want the output in any sequence format. Provide me the last output. If at all this is the last layer, right? How do you generate the final output? Give me in that, right? So that's the binary HTML, right? Again, I need, now you see, I don't want to do a dropout, right? Because I'm going to the very last layer now, no dropout over there. If you remember the basics, right? Directly give it to which layer, right? Everything you connect into a single layer called as a fully connected layer. Fully connected layer, right? What should be the size? That should be number of classes, isn't it? How many classes you have? That's so. Once you have that, you need an activation function. What is the activation function of your final layer? Correct? Softmax. Softmax. Then I have to, right, use the, because my output is a class, right? I have to go for a classification, right? So that is defined as classification layer. Okay, let me try to run this and see whether this will be created. Okay, so also we can actually, if I want, I can use a disp as well. So let's save this and number of hidden layers. Oh, it's just num of. I'll correct here. Okay, it's layers. Sorry, that's the error. Yeah. Okay, now it's clear, right? We have 1 into 7 layer, right? With layers, right? You can see sequence input layer, wireless team layer, 20% dropout, etc. Everything you can see. All right. So what are the layers you can? So you see, either you use the layer graph we studied in the previous example, right? Where we try to plot the layers. Now I'm showing you how to see the layers, not in the form of a graph, right? But it's being displayed on the command window itself. Okay. All right. We'll go to the new thing. And here I want to give the training option and I want to start training. All right. So what I do, I'll use the random numbers generated, right? Because out of the data I have in the nums, right? I don't want to fix, okay, only these uh, data will go as a training part. Every time I don't want to do that. Okay, what I want to do, I want to take the numbers random. I'll just specify that, okay, out of 5200, maybe take 80%. What is 80% of 5200? Let's do that. 5200 into 0.85. Okay, if it is 80%, then this should be 4160. Okay, I just want to specify that, right? Check any 4160 of 4160 entries of this numz as the training data. Okay, so when you take 80%, remaining 20% is what? That is the test data, correct? So I want to write a code that MATLAB takes care of this automatically. In the sense, I'll just specify, okay, 85% you do this, right? Remaining you take it for the test. Okay, fine. So let's try to put this now. So I'm going to use a function here called as, say, it's called as a random permutation. So permutation is nothing but, right, arranging, right? Randomly arrange so many number of data from the given data. That's what is my question. Let us say, let me try to show you that. So help random perm. So it's actually a random permutation, right? So you see, if I write, I'm going to use in this format, n comma k, returns a row vector containing k unique integers, right? Selected randomly from 1 to n. So if I write 6 comma 3, it returns 3 elements from 1 to 6 selected at random. You see, 4 to 5, random, correct? Next, if you run the same thing once again, rand perm 6 comma 3, it will give you a different answer. So it's not going to give you the same answer every time. Okay, right? See, 643 156. Again, I'm running the same thing. You see, every time it generates different number, but it generates the same size as you expect. Correct? So now let us use that. So I'll try to generate the index first. So right, maybe that is for index string. In the sense, out of the 5200, which numbers, which are the indices that are going to be used for the training purpose, right? So a index string should be equal to, use a rand perm. Randomly you generate up to what number? Up to the, already we know the size, it's n, right? I need any number up to n within the 5200. So this is n. How many numbers you want? I'm saying that I need 80%, right? Right, so I'll write maybe uh, train ratio. Training ratio is equal to, let's define that, 0.8, right? 80%. So this is uh, the train ratio times training ratio into, right, this n, isn't it? Are you okay? Are you okay with that? So let's try to run this part of the code and check what happens. Okay, okay, this train ratio is also not defined, so it's going to throw up an error. So let me avoid that. So right, so train ratio is equal to this. I want to do this. Now you see the train ratio is there. It's created over there, 80%, 0.8. Now you see the index. So as I told, I'm going to generate random numbers. What is the size? 80%, 4160. So out of 5200, 80% is 4160. I generated 4160 numbers at random. You see, what is the maximum number? 5200. All the numbers are within that. Okay, so up to the 4000, you can see the same size. 80% numbers have been created. Okay, now whatever numbers are not here, they will go for the testing purpose. Is it okay? Which means that data will be the test data, correct? Right. Now you see, how do you generate that? Okay, let's go to the testing part later. I created the indices for the training, right? What I do, I'll do the X data for train. X train should be equal to, so X train is equal to, from where you need to select, it should be present from the take, it should be collected from num z, right? Right. So this is S dot num z of all the indices that come from the index train. Okay. From the index train, take this and call it as X train. Right. Now I just want to do the Y test as well. The result of the training, not test, should be equal to, once again you are collecting from where, it's collecting from the C now, but now you see you have to make a very specific declaration that this is a categorical data. It's a categorical data, right? Collect it from S dot C, right? Select all the corresponding, right, what you call the indices, right? So that is index thing. Let's see whether we can run this without error. Yes, it runs. Okay, corresponding to each of them, you see you have created a X train, right? So that's your X train. And corresponding to X train, you have Y train. That is, this is the right answer. First one, second one is wrong, right, wrong, 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 right, wrong, wrong. You see, like that, it has been trained. It's this the categorical data. Is it okay? Anyway, so that is done. Now, similarly, I just have to do the collect the other values into the testing part. So I got an index train. I need the index testing. Okay. For testing, what you do? So there is already an index train created. Just to see what is not there in the index train. So for that reason, for that we have one function that is called as set diff. Not capital, so it's a small set diff. So let's see what is set diff. It's, as the name suggests, it's a difference among the sets. So I'm trying to use the set A comma B this form. Okay. So vectors A and B returns the values in A that are not in B. Okay. So B means I'm going to use the index string. A, I'm going to use 1 to 5200. Yeah, among 1 to 5200, whatever is not present in index string, put it into the index test. That's correct, right? So set diff 1 to n, that's 5200, starting from 1 till 5200. See what is not in index string. Hope hope it is clear, right? So what setdiff does, it checks this, and whatever in this is not present in the 1 to n, 1 to 5000, if it is here in index train, that is not going to be updated to index test. Say 200 is not in index train. So 200 will be compared with 1 to 5200. So if the 200 is not here in the index train, 200 will come into this, into the index test. Okay, fine. So let's write the next one. So once I got an index test, I should generate the X, that's the data set for testing, right? Once again, same thing. This is S dot Z of, right, index test. So for training, it's coming from training. Testing, it comes from the test. So Y uh, y test should be equal to same thing. It's a categorical data coming from s dot c, the testing. So the testing in a sense index. Okay, let's try to run this part. Everything is running. So okay, right. So that's done. Now what's the next option before training? I need the options. Correct. I have to tell the options of training. Options should be equal to training options, right? Whichever you want, you can use. Okay, I'm going to start with the ADAM technique. Not to be specified the others in the new testing. So I'll say the max number of epochs. Maybe I want to restrict to 200. Let's see. Later on, you can definitely modify. If it is not working, not learning properly, definitely change. Okay, then I can specify the gradient THRE episode. SHO gradient threshold. Define this to say 1 now as a gradient threshold. Then you need to validate. Okay, so let's go for the validation data. Validation data should be okay. I'll use the same training and the testing data. Okay, so x train comma x y chain. I don't want the machine to know the testing data. That's why. Okay, so testing data still remains unknown to the machine. Right. Then you say how you want to perform the validation. So you can say that validation frequency say maybe I want to do the validation at every 50 training. Okay, we can change that the data stage. Let's go for the do you want to see the results? Okay, so in the sense in the form of a table, do you want to see? Yes, so I'll give a verbose. That's a verbose. You can write it true or false, or even you write 1 or 0. That both are accepted. Okay, I'm making 1 here indicating that I want to see. Then do you need to see the plots, training plot? Yes. Okay, plots. Specify what you want to see. I want to see the training progress. Okay, now you see instead of visualizing this options in the form of any graph or something, we can have an option like a display. This options that will directly display. So I'm actually showing you the different methods of visualization. Okay, that's also going to be very helpful. Use it. Now you see I'm able to see the complete training options, right? So everything is defined. Everything what you want, you can see. This is what is the training options that you are using, right? So something we have not used, in that case, it is going to show you what is the default one. For example, you see execution environment, it is set to auto, indicating that if there is a GPU in your system, it will take the GPU, otherwise it will take the CPU. So automatically it will identify and okay, so something like that. So that is done. So Once this is done, we can go to the next category where we'll start doing the training. All right, so use the perform the training and put it into the network called the net train train network, that is x train, y train, layers, and options. Okay, so let's see whether this is going to train or not. Let me save this and let me run this section. So you see, we are expecting a something like, we have given the verbose, so I'm expecting the verbose to come here. But as of now, it's still starting the training process. Okay, as it proceeds, we expect the verbose to come here. That's a table should be coming up. So is it visible? Can you see that that's the training on a single CPU? It's actually, I can see that, right? Still taking time. So far you can see that, right? So many epochs are over. Accuracy is still, uh, validation accuracy is very close to 80%. Okay, 80.19. Mini batch accuracy is slightly varying, 79, it came down to 77, 81, once again 79, and so on. Okay, let's see. Okay, uh, testing is completed. Still it is showing busy. Let's see. Completed, not completed, sorry. Because, okay, it's still at 50. Epochs will go till 200. That's what is the number we entered. So I didn't know how much time it's going to take. So randomly gave it 200. But anyway, it looks like we can give a lesser number also. Because the learning curve is almost a straight line. The validation is still at 80.19. I think maximum 80% we might get here in this case. So that means we need to change the parameters so that it achieves higher recognition rate, right? Something needs to be changed. Maybe you can add more training data by reducing the training ratio, sorry, increasing the training ratio, right? The training ratio in this case is 0.8. Definitely you can change it to 0.85 something. Okay, more data you can give, right? Epochs can be increased, gradient threshold can be, right, very varied, right? This can also be varied, etc. You can make all those changes as you require. Let's see the result once it gets complete. Okay, we'll do one thing. Let it run. Let's write the code for the testing part as well. Is it okay? Yeah. Okay, so that means you see we have this. Okay, I need to test this. So testing code. Let's call the predicted answer by the machine by y predicted. Okay, this is by the machine. So the command you use or the function you call is a classify. Okay, it classifies what you want to classify. You want to classify the test data using the network that has been trained. So network that has been trained is NET, correct? So net, so classify using the network this data, that is X test. So you see, Y test is not given, machine does not know what is the expected answer. Okay, so result comes in Y predicted. So you use the same logic to finding the accuracy. So like previously we used the ACC accuracy is equal to, I just have to find the sum of the numbers that are properly classified as Y predicted equal to the Y test, right? So this is what I want to calculate. This sum, I need to divide this by the numerical length of NUML, sorry, not length, NUM, numerical length, NUMEL of the Y test. Okay, so this itself is the answer. So this, okay, right? So that's the code we are going to check next. So I'll just separate it by another this thing. So I don't have to run the training once again. Directly I can go for the testing. All right. So let's wait 40 more epochs to go. But it's you can see that there is no improvement in the uh, validation frequency, right? It's 80.19 throughout, right from the beginning. So it means, right, learning is not happening as expected. We might have to change this, but anyway, 80% is not bad, right? But not the not the number which we are expecting for CNN, right? Normally 90 plus is expected. It's close to that, 80%, right? Not bad, but not the expected. That's all. Okay, right. Anyway, so you have the option to modify the network later and check what you can do to bring it to above 90%. Okay, so that's what I am going to leave it to as a maybe a homework for you. Okay, right. So let this finish. Now it is 172. Once once done, then we can run that. Now it's the last one. Looks like Okay, so now the training is over. Right? Let's directly go to the testing part. I'll run this last part of the code. As you can see, I do the predicted value from the machine. After passing the testing data to the network, it will classify and gives the result. I'm comparing how many of these results are same as in the Y test. Y test is the actually the known answer, like a ground truth. I'm comparing how many of Y predicted are equal to that, taking the sum of that, right? Wherever it is equal, I'll take, it will be 1 because this is a conditional statement. You see, equal to, it's true means it will take a sum. Whenever you have ones, that will be summed. Divide by the total length, will gives you the accuracy. Okay, so let's just run this. So as you can see, 0.7923 is the final accuracy, 79.23%. Right? Looks like more practical data now. There is a lot of, maybe some of the words are not in order, something, right? There is something. This is the more practical data, right? So because of which you have something like this. Now the same thing, right? You can actually extend if you have a data properly, what you call properly defined data set, right? This is just an idea. You can try to build a project by yourself. Collect a data set in this format, right, where you have each sentence corresponding to maybe human emotions, like something positive, something negative, either positive, only two classes, not multiple classes. You can generate, or somewhere you may get that data set readily available, but just bring it into the required format. Okay, so sentence by sentence you put first sentence, second sentence, third sentence, etc. Each sentence you may classify that into like instead of abcd you can put one for a positive statement, zero for a negative statement. That's all, right? 1010 you can put here. I don't need all the 5 cases here, right? Then you can modify, try to modify these codes we have written so far, right? And you can convert them into a human emotion recognition system by using the deep neural networks, right? So that becomes a mini project for you once again, right? Any of this, whatever we have done so far, right? Try to modify it in your own way so that you can call it as your own project, and if required, you can publish a paper as well on that, right? So that will give you a good recognition, and that helps you in building the resume, right? Whenever required. So that's the ultimate target. So whenever you build a resume, it should be really good. That's our objective. So that's why I'm trying to do projects in this session as well. Okay, right. So anyway, we'll stop here for the day.